Okay guys, in this video we're going to talk about problem solving, and in particular we're going to deal with dimensional analysis in terms of how we solve problems here in chemistry. Now, no matter what class you're in, no matter what you're doing, there's always 3 steps to solving any problem, okay? So those steps are identify what you know, identify what you want to know, and then plan a way to solve it or map it. Okay, so a lot of times in class, if I'm doing this, I'll talk to students about let's take a look at mapping something out. Okay, no matter what you use, if you use a paper map, if you use Google, if you use your navigation on your cars, whatever it is, there's always the same type of process. Okay, the first input you need to know is where you are. Okay, so you can't figure out where to go unless you know where you are, and then next thing you need to know is where do you want to be, okay? So that's the second thing that you would maybe input, let's say, into a map type of process. And then finally, if you're doing paper maps, you can actually map it out yourself. But if you're using a computer or a mapping program, then they just take the 2 spots, they go through all their information, all their databases, and they decide what the best course of action is for you. Now, the same thing happens in any chemistry problem solving, where you need to start with the information you're given, decide what information you want at the end of your problem, and then build that map to get yourself through that problem, okay? So the first thing you want to do is make sure, as you're going through and calculating, okay, you want to make sure that you take the proper steps to solve the problem, okay? You want to make sure that you record your answer with a label to the proper significant figures, okay? And for my help, just box your final answer for me. That'd be great, okay? So as you're working through and calculating, make sure you do your steps and then do the following things. Now, when you're done with your problem, this is a piece that I think a lot of students forget, is they forget to check their work, okay? There's a lot of times in chemistry you can do a little bit of mental math and ask yourself the question, does this make sense? Yes or no, okay? So let's say we look down these 2 examples here. You calculate your mass to be 5,600 grams, okay? So 5,600 grams. Now you may not be super familiar with grams, but you have to have some sense of what a gram is, okay? So 5,600, does that make sense or not, okay? It's like, oh yeah, I'm 5,600 grams, great, awesome. Or does it be like, wow, that number doesn't make sense whatsoever, okay? So let's think about it, okay? We know that pounds and kilograms are somewhat close. Okay, they're not exactly the same, but they're somewhat close. So let's quickly mentally convert this to kilograms and see what happens. Well, the grams to kilograms is 1,000 difference in conversion. So if we slide the decimal over 3 places, we get 5.6 kilograms. Okay, so even if you don't know the relationship between pounds and kilograms, you know that they're close enough to each other that you don't weigh 5.6 kilograms, or even if it was double or triple, you don't weigh 15 pounds or 2 pounds. We should be, anywhere from 90 to, 200 plus pounds is the range of people. So this doesn't make any sense whatsoever, that your mass would be, 5 kilograms or 10 or 12 pounds. It makes no sense. However, if you go down to the next one and say, oh, density of sugar water, 1.03 grams per milliliter. Okay, you know that water by itself is 1, and if you add a little sugar in, probably going to get a little bit more, right? So yeah, that number is realistic because water by itself is a 1, and sugar water, yeah, it would make sense if you add more stuff into the water. Density might change some and probably will go up a little bit. So this number does seem to be pretty valid to us, okay? So quick mental math to help us evaluate whether or not our numbers make sense or not. That really will help you out a lot as you go through the class, okay? So here's our no and our yes. Now, the problem-solving technique that we use in chemistry not exclusively I shouldn't say, that we use extensively is the word I want, throughout the entire year is dimensional analysis, okay? We're using the dimensions to analyze our problem, okay? Thus dimensional analysis. Now, what dimensional analysis does for us, it allows us to use equalities, things that are equal to each other, to convert from one unit to the other. And really, in the world of chemistry, that's what a lot of our math is we're taking known values and finding relationships to find out new information, okay? So it's going to use those units to guide us, okay? And I always say, absolutely, there are other ways to solve some of the problems that we're going to be doing in here. There is, lots of ways you can tackle some things, but I will tell you this, as the math gets harder and the chemistry gets more complex, dimensional analysis is the most systematic and the most used method that is out there. Okay, so it's basically the kind of that go-to way of doing math in chemistry. So we definitely got to handle some dimensional analysis. Okay, now last but not least, kind of keep this last statement in mind. So I'm not really here today to teach you about the chemical side of dimensional analysis. I'm here just to show you the method, okay? The problems we're going to take a look at are not real challenging, and you probably could do them in different ways. You could probably do some of them just straight through your calculator, or maybe even in your head, okay? The goal today, though, is to show you the method. So I'm going to show you the steps to a dimensional analysis using relatively easy math. Okay? The reason why I do that is because not too long from now, we're going to start getting into some math that's more complex, some chemistry that's harder, and we want to be able to use dimensional analysis without having to think about it. We don't want it to figure out, well, how do I do dimensional analysis? We want that to be a tool that we can pull out of our toolbox and just use to make this thing work. Okay? So that's kind of our plan. So one thing we need to make sure we take a note of that in our tests and quizzes in here that we do in class, I'm going to give you a TI-30X2S calculator. Okay, it's a 2-line scientific calculator. The benefit of having this calculator over one that you may have in your pocket is simply the fact that the batteries won't be dead. Besides that, it's not better probably than your calculator. It's probably actually a little bit less than the calculator that you have. However, I know that every student has one, that it's consistent, and I also know that there's no information programmed or stored on these calculators when you get them for your test. So it's a security thing, and it's also a consistency thing that we're using here. So just be ready for that. Some of those fancy converters and that kind of stuff on your TI-84s or higher calculators, they work okay, but sometimes they actually have problems. They might give you the wrong answer, to be honest with you. All right, so within this process, there are a few different conversions that you need to be able to do and pull from your brains. First of all, SI system prefixes, the ones that we had on our list earlier in this unit, you need to know those, okay? I will assume that you know basic SI conversions, 3 feet equals a yard, and so forth, okay? So if you don't know those basic things, please talk to me, because it's kind of my assumption that you are comfortable with 3 feet equaling a yard, 12 inches to a foot, and so forth. But there definitely are people who are in my class who may not have lived in the country as long as all of us, some of the rest of us have, and this may not be as familiar to you. So if that's the case, okay, if you're not native to the country, we're not born here, and you want a little bit extra help with that, please let me know. I'll definitely help you out, because my expectation is that not that you would know our system, especially if you've only moved here in the past 2 or 3 years. So I'll help you with those kind of things. Now, there's 2 down here that you got to just put to memory. Okay, 1 milliliter equals a centimeter cubed. Okay, that's one of them. And the other one is that 2.54 centimeters equals 1 inch. This one is kind of key because this is the only conversion between the imperial system of feet and inches to the metric or SI system of centimeters that's exact. Every other conversion that you may look up is an approximation or a rounded off number. So there's nothing after this 4. So there's exactly 2.54 centimeters in 1 inch. This is a true equality. There's no measurement based on this one. So this is kind of an important one that we kind of use as we go through.